Right, so we're going to look at solving inequalities. So we did some of this earlier in the year, but there were some topics that we didn't get a chance to look at. So what I'll do is to do a quick review of the section that we looked at, and then we take our time with the other sections that were not so familiar. Right? Cool. So quickly, solving inequalities. So we would have looked at some of these already. So an inequality involves one of four symbols. The following statements illustrate the meaning of each of them. X is greater than 1, and they give it in words right here. X is greater than or equal to -2. X is less than 10. X is less than or equal to 12. So some persons have a difficulty knowing what is greater than or what is less than. So wherever the open part of the arrow, right, that is the whatever is on that side is greater than what is on the other side, right? Or another way you can think of it, the arrow points. If you think of it like an arrow, it points to the number or variable that is less than the one on the other side. So either way you can look at it. I usually look at it as the part that opens up is the one that is greater. All right. So inequalities can be represented on a number line as shown in the following worked examples. And we did this earlier in the year, as I said. So just a quick recap. The inequality x is greater than or equal to 2. On a number line, when represented, you have this shaded circle here, which represents equal to, and then you have the arrow pointing to the right, starting from 2, tells you that it is greater than 2. So say that again, the shade above the 2 represents that it is equal to, and then the arrow starting from 2 going to the right means that it is also greater than. So that's where you get x is greater than or equal to 2, right? And it says here, the solid mark is used at 2 to show that this value is included. And then here the inequality x is less than -1 states that x must be less than -1. This is represented as shown. So you have, this is just a circle here, a small circle, not shaded. And then you have the arrow pointing to the left, starting from -1. And it's, it gives the concept here. Note that a hollow mark is used at -1 to show that it is, to show that this value is not included. And then here we have another one, the inequality. You read it by saying x, you start with x is greater than -2, but less than or equal to 4. So the fact that it is greater than -2 and it does not include 2, then that means we're going to have a hollow. They call it what, a hollow mark. Let's use what they say, hollow mark. I prefer to say hollow circle or unshaded circle, right? And then the fact that it also includes 4, you have a shaded circle. And then the fact that it's between -2 and 4, that's why I connect the lines between -2 and 4. And that's really it. And it's a right hand inequality. So I have some examples. Right hand inequality to describe the region represented on each number line. This is x is less than or equal to 3, right? So equal to, shaded, less than. Here we have x is greater than or equal to -1, but less than 3. So if it's something that you're not clear on, you can ask me. Otherwise, I would advise that you try some of these examples or exercises on your own. I'll provide the solution sheet and you can just double check. So this is not a big deal. You guys supposed to see this already earlier in the year, right? So I'm gonna skip through. I have some worded questions here. The speed limit on a road requires drivers to travel at a minimum speed of 30 and a maximum speed of 70, right? And it just represented on the line. So no big deal. List all the whole numbers which satisfy the inequalities. It lists all the whole numbers, 1, 2, 3, 4, 5. So for this one, I include 8. So this is a 1, 2, 3, 4, 5, 6, 7, 8. This one, you exclude 3, so you start off by saying 4, 5, and 6, you exclude 7. So nothing that you would not have seen before. And as I said, I provided a solution sheet. Now we get to somewhere more interesting now. It says solution of linear inequalities. And I'm sure I also did some of this. So I'm going to just quickly run through again. So inequalities such as 6x minus 7 less than or equal to 5 can be simplified before solving them. This process is similar to that used to solve equations. And it's straightforward. So you have this, the whole, add 7 to both sides, you get 6x is less than 12, and you divide both sides by 6, you get x equal less than 2. And x equal less than 2 represent our number line. So x equal to x less than or equal to 2. You have the shaded circle here, are pointing to the left starting from 2. Nothing out of this world. We saw some of those early in the year. Solve the inequality. You have 4 times x minus 2 in bracket is greater than 20. You can divide both sides by 4 straight off if you want. You get x minus 2 is greater than 5. And then you add 2 to both sides, you get x greater than 7. Right? So here's the answer. I will continue along the same vein. It only becomes a little, I wouldn't say tricky, but I guess I can call it tricky when you have a minus sign dealing with. You just have to remember to switch the signs, right? And as I say, you guys would have seen some of that earlier in the year. Going again, solve inequality. So I think this is where it gets interesting because I know persons rarely say this type, but I've seen it in a CSEC example before. I think probably only 1 or 2 times. Solve the inequality. So take note of this one, and maybe I should bring up a screen to drive the point home for this one, bring up the PowerPoint. So give me a second to do that right now. Because I know it may not be so straightforward, right? Give me a second. See if I can carry this over. All right, hopefully you guys can see this clear as day. So let's start with the question. Let me see. What's it minus the drawing tool? So black. All right. So minus 10 less than 6x plus 2 less than or equal to 32. You guys can see the screen, right? Hopefully.
Yes, I'm seeing it.
All right. So this one, you're trying again to get x by itself. So all you need to do is do as you would normally do when you are solving a simple linear equation. You just isolate for x. So in this case, you need to subtract minus, you need to subtract 2 from both sides. But in this case, it's not just both sides. I guess I could call it three sides, right? So you subtract 2 from here, 2 from here, and 2 from here, and you leave back with 6x. So you have it looking like this. And then, yeah, you need to get x by itself. So you divide all sides by 6. So you get minus 2. You get x by itself. And you get 5. So that's how it's done. All right. So let's continue. So, and as I said, this result can be represented on a number line as shown below. And they show you here. An alternative approach is to consider inequality as two separate inequalities. Right? Which I think is lame. I wouldn't. You get the same answer and we can go through it, right? Duplicate, so new slide. So what they're saying is, let's go back. Let us make sure we have the right thing. So minus 10. So you take this section here up to this inequality, the less than or equal to. Let's say break it up in pieces, right? So you'd have minus 10 less than 6x plus 2. And you work on that. And then the other side now, you would have, so 6x plus 2. And I think we had almost 32. Yeah, almost sure. Let me check. Good. So you can break it up in 2. And then it's all right, you work on this by itself. Subtract 2 from both sides. 6x, divide both sides by 6. You get 2. Right? So this is one part, and then put the minus sign. Then here now, subtract 2 again. You get 6x. That 30. Divide both sides by 6. You get x 5. Right? So you get x is greater than minus 2, and x is less than or equal to 5. So if you were to join it, it makes sense, right? Because x is at the same, so x is greater than minus 2. So you just put x in the middle because it is greater than minus 2, but it is less than or equal to 5. And you get your answer. So it is the same thing, kind of lame to split it out when you can just work it nice and easy the first way. All right. So I would encourage you guys to try. So Shauna, I would encourage you to try. I know you should be good with doing these, right? But there's one thing I want to highlight with the simple ones. I want to make sure that you remember about the minus sign and how to treat it. So let me see. I like how this one looks. So you see, let me see, try a simple one with no issues. It's supposed to be straightforward. I want you to try this. Solve the following inequality. Try this. Or better yet, try this because I want you to illustrate the solution on a number line. So you can try D, this one, and then I want you to try G and K, right? So I'll give you, this is supposed to take 1 minute. So 3 minutes in all. So D, G, and K. Try those. All right, so we're going to look at D. I mean, we can freestyle it. Let me see. Oh, but we need to draw the line. Maybe I can speak to it. So you add 7 to both sides, right? So that's what? 5x greater than or equal to minus 10.
Minus 10.
Then you divide both sides by 5. So that is x is greater or equal to -2.
minus 2. Yes, sir.
All right, and then when I draw the number line now, you're going to make sure it says a shaded circle over the -2, and then the arrow is pointing to the right. Right? As in you point it. All right, good. The next thing now is what G. So G, let me carry this up because I want you see this little thing that I want to point out. So G is 4 so if you're -4 from both sides, so you're gonna get
minus,
right? Now,
yes, sir.
in the next line, what I'm gonna do, I'm gonna divide both sides by -2.
Right.
But in the line that I do the division, I'm gonna change the sign because I divide by a minus number, negative number. I have to change the sign.
On the other side.
So hopefully you remember that piece, right? So once I divide or multiply,
I didn't remember that little part.
yeah, and that's why I'm gonna bring it up. So this now you can get 6 right here. So I'm not even include another sign. I'm going to just put, let me just put it like so.
Yes, sir.
And so this is the 6. So let me just catch on a little piece here. So x is less than or equal to 6. So that is the answer.
Yes. Okay. Hold on. Yes.
The next one is what I did say. Okay, all right. So same treatment for K. 6 minus 5x greater than 10 minus 6 on both sides. Divide both sides. So I don't want to do the division here because I want to make sure that when I do the division, I change the sign in the same line. So let me change the sign first, and then I put a divide by -5. All right, so this gone. So I leave back with x. So this is what 3 and 1/5. Right. Yeah. Okay. Good stuff. So that's how you do that. Let's move right along. Make sure that the thing recording good. All right. So we have these now. And I'll show you how to do them from before. The same treatment, right? Maybe I do an interesting one. Let's try E and F. Those look interesting. Can probably try D too, since it have a bracket. All right, let me do E first. So we have a half, right? And then we'll have 4x plus 5 over 2 less than or equal to 1. So remember when we're doing the simple linear solving for the simple equations where we have fractions, we usually try our best to multiply out by some number to remove the fraction, or we find the LCM. So it's a similar treatment. We say that 2 is in the denominator, so we just multiply through by 2. So if you multiply this side by 2, you get 1. If you multiply the middle here by 2, the 2 cancel, in the denominator, you just get the numerator 4x plus 5. And if you multiply this side by 2, you get 2. And here you just have a regular situation. Minus by 5 throughout, you get a minus 4 here. You get 4x, you get a minus 3 here. Then now you divide through by 4. And this becomes minus 1. You have x. And then this is just, yeah, this you can't really, unless you write as a decimal, you can just satisfy like that, right? Cool.
Yes, sir.
So this works. Let us find something else. So let's say f. So for f, we'll have all right, multiply through by 5 to get rid of this denominator. So we have 5, and then this becomes 35. And then we'll add 1 throughout. So this becomes 6x 36. So this comes out nicely. Divide through by 6. Get 1, get x, and we get all right. Make sure everything fine. So this is saying that x is less than 6, right? But it is greater than 1, which is fine. All right, so that's how it's done. And for D, so D is very simple, but we can try. So D is just, you just have a bracket, that's all. So you can either choose to multiply out the bracket, or you can divide through by 4 first, whichever way you prefer. Let me see if there's if one will yield something simpler than the other. Let me say that this is 12. Add 12 to both sides, add 12 to both sides, and divide by 2. Maybe not. So I'll say instead of dividing by 4, I'll multiply out. Right, either way you can do first, right? So carry bucket 3. Then now you add 12 to both sides. So this now is what so you're adding 12. So positive, negative, that's a 4. 8x. And then add 12 to this side, and you get 15 divide through by 8. This becomes a half. This is x. This is what? This is 1 and 7. All right. So moving right along. So everything else now is like we say like some wordy question. Clayton owns a barber shop. It costs him $20 per day to cover his expenses, and he charges $4 for every haircut. Explain why his profit for any day is this, where X is the number of haircuts in that day, right? Boom, boom, boom. Yeah, as in, this is straightforward. Because if every haircut him charge $4, then that's the unit cost per haircut, and X is the number of haircuts. So you have 4 times the number to get the income, and then the expense section is just as it says, is overheads for operating a business. So you have income minus expense, which is a profit, right? So that works well. He hopes to make at least $50 profit per day, but does not intend to make more than 120 profit. Write down an inequality to describe the situation. So this is at the floor, and this is the ceiling, right? So we can look on it. So a question like this, I would like you guys really to dig deep. I'm not going to do everything, but just to show you how one would approach this. Because this is like a nice little reasoning question, right? What them do, them set it up and say, all right, this is like the profit function. I'm gonna want to make it sound fancy. This is just how you would calculate the amount profit. The number of haircuts that times the I guess they call it the charge that them charge the people per haircut. So this is in income and in expense, right? And then him say right here, so this is the profit in any given situation, profit for the day. And then this now say he hopes to make at least 50 in profit, right? So 50 profit per day, but does not intend to make more than 120. So you can just drop this here in between 50 and 120. And that's what we're going to do. And then basically to solve the inequality, you're basically solving for the number of haircuts, right? Because that's what it says, where X is the number of haircuts. So we're going to quickly look on this. So it's a 50. So that means this here, his profit has to be greater, at least 50. And you know, I'm not going to push it above 120 for the day. And I solve for this. Right? To take more, does not intend to take more than, right? And that give you the idea that he's willing to take 120, but no more than 120. So this less than or equal to 120 can work. And then we solve for this, and we know how to solve for things like these, right? So in a situation we add 20 to both sides, we get 70. For X, we get 140. And then we divide both sides by, not both sides, all sides by 4, right? And whatever that work out to be, you can tell me. Let me see. Cancel 4 into 7. 1 time remainder 3, and then 4 7's 28. So we have a remainder 2 over that, so this looks like 17 and 2 over 4, which is that. Then we have X, and then 14 divided by 4 is what? 3 4 is 12, remainder 2, 4 into that 5. So I have 35. Right? And just to make sure, use my calculator. So 70 divided by 4. All right, so I'm good. All right. So in order to hit his target, he needs to say, obviously, you know, we have 17 and a half haircut, right? So he's gonna have to trim at least 18 customers for the day, up to a maximum of 35 customers. I'm don't need any more than that to hit him target. All right. So the rest of these, of course, I can look at any more of these questions, or else I'm not going to finish. So I would advise that you attempt as many as I can, and as I said before, I'll provide the solution sheet. All right, so inequalities involving quadratic terms. Right, so here is another one. I'm almost sure that you guys did some of this already too. But I'll just quickly go through. Inequalities involving x squared rather than x can still be solved. For example, inequality x squared less than 9 will be satisfied by any number between -3 and 3. So the solution is written as -3 as x greater than minus 3 or less than 3. And they represent on a number line. Again, it's in between. It's not equal to 3, so these things are hollow circle at the endpoints. If the inequality had been x squared is greater than 9, then it would be satisfied if x was greater than 3, or if x was less than 3. So the solution would be like this. The endpoints of the intervals are defined as plus or minus 3. All right? Looking for something. Okay. It is less than. All right. And they ask you now to do some here and here. All right. So they have this thing where they say points and they're talking about tests and all these things. But for me, there's a way that I do it that I don't need to really test anything. So let me show you real quick what I do. All right. Oh, what I need to say the question though. So it's a solid inequality. So x squared greater than 0. All right. So I will borrow and this factorization, and I don't even think. I just know that all right. So I know that the endpoints are, so to get the endpoints, just think of it as being equal to and solve for x. So if this was x minus 4 equals 0, then x would equal 4. So x, say endpoints, probably I can put it somewhere else. So you know you're working with, what it is. So you know you're working with x equal, I'm put endpoints. X equal 4 and x equal minus 1. So these are the points that you're working with. All right, so what I would normally do is to draw just a little sketch, and I put on my endpoints. So a sketch of the curve. I know it's parabola and it's up like this, right? Where the minimum is at the bottom. So I know that minus 1 would be here and 4 would be here. And it says that the graph is above 0. So above 0 means that, you know, it's, how can I say, it's above the x-axis, all right? So if you think of the 0 point here, say I had 0 here, and I draw this y-axis, right? Then this is just saying, tell me where the values are above y equals 0, and they are outside here.
Out.
So my answer would be x is less than minus 1 or x is greater than 4. And just by doing a little sketch, I can tell you the answer. So let us see what they come up with. So this is what they do. They do this thing where they test points in each region can be tested. X equal to gives that, not true. That, I can't bother with that, right? So by doing this little sketch, right? By doing this little sketch, you can get the answer straight off. Let me do another one. Do, 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 do. You know, the one that I had to work out too tough, you know. All right, let me try something. All right, so this should be like worked out already for me. Let's try one. All right, try one, anyone, right? Let me try this one right here. So we have less than equal to 0. So then factorize this. This is something that you guys need to practice in a mind. So I have the endpoints. So x equals 0 and x equals 6. So these are the endpoints. So if you were to sketch this, this is something that is curved up like so, the minimum point at the bottom. And the minimum point, if you remember your quadratic, is just this point, the lowest point on the curve. All I'm trying to do is draw a horizontal line. All right, this will work. So this could be my 0, x equals 0, and x equals 6, because 6 greater than 0. So, right, so this works. Now, this is saying that the graph give me values below 0, and this 0 represents the y-axis, you know. So you want values below 0. So you want these down here. So this line, all right, not so nice, but let me see if I can draw a better one. So 0 and 6. So these are your x coordinates for this curve. So up here, let me highlight, up here represent y values that are greater than 0. And down here, try to find another color. Down here represent y values for the graph that are less than 0. You may wonder, sir, what are you talking about? What I'm talking about is that if you have the y-axis here, then this would be 0, 0, meaning this is x equals 0, y equals 0. And we're saying that this section here is below 0 on the y-axis below here, and these represent values above the y-axis. So this saying less than 0, you want values down here. So values down here, you find that when the values on the graph here, the values on the line here are between 0 and 6, you end up below the y-axis. And that's all it is. So you end up below the y-axis for values between 0 and 6. They say, all right, the answer is just, right? And you take, so because this is less than or equal to whatever answer you get must have the, you know, if it's greater than or equal to or less than or equal to, it will include by the less than or equal to, right? And that's where you get to say, know that you're looking for values between 0 and 6. Anything between 0 and 6 will land you below the y-axis. All right. No, the one that we did before, you want to make sure it's clear. One that we did before is like so, where we say, all right, x is less than, or maybe I should use a green since I was using green for above. Let me use green. When x is less than 1, it is above the curve, and when it's greater than 4, it is above, and that's above the curve, above the x-axis, right? Now, notice how I write this. I say x is less than -1 or greater than 4. It could not have been written any other way. Some persons may be tempted to write it like this. which would be wrong. I know the temptation is great, but it would be very wrong because x, if x is greater than 4, then -1 cannot be greater than x because you'd be saying that -1 is greater than 4, right? So the temptation is great. When it is like this, I have to put x is less than -1 or, but when it's in between, you can write it the way I had it on the other slide. So let me erase this somehow. Let me see. All right. So that's enough for that. What I'll do, as I said, when I give you the solution sheet, you can just work some questions. And if you use this method, you see that it comes with practice. It will be simple, but I would say definitely attempt these. These are good. And these nice worded questions too. These are good stuff, right? I'm not even gonna attempt them right now. So the following inequalities, you go through when you go through. All right. Here now, the graphical approach. When an inequality involves two variables, the inequality can be represented by a region on a graph. For example, the inequality x plus y, and you guys did some of this before. I'm trying to build up to linear programming, right? But I know that I can't just drop on linear programming just like that. I have to kind of build up, right? So I know you guys touched some of this already, so I'm not going to spend too much time. When an inequality involves two variables, the inequality can be represented by a region on a graph. For example, inequality x plus y greater than 4 is like this. So it's everything over that satisfies this region. So this is shaded region. All right, and then notice that it says greater than or equal to, so the line is, I guess I call it a blocked line. Let me say how them describe it. Oh, them not really mention the line. I know some person represent, speak of it as a blocked line. If the inequality had been like so, then a dash line. So I guess you could call it a regular line, right? And then you have a dash line when it is greater than 4. So this time it's not equal to 4. So you put a dash line. So the question for some persons is, sir, how do you even come up with this line? Right? For some persons that would be the question, how you come up with the line, sir? Well, as I said, I don't want to go over too much. Let me go here, new slide. All right. Why is this right here? Delete this. Can't delete. It just in the way. And it's not moving. All right, and that way make it be a bottom. All right, so let me see if I can actually do something. Nope. So I have x plus y greater, I think we had greater than or equal to 4. And what have, so I have a, all right, let me attempt using this for a second. Let me attempt. All right, it's okay, finally 90 degrees up here. So finally a straight line. All right, let's see now. All right. Or maybe I'll put it slightly in the middle. Yeah. All right. So get rid of it and say this is 0. 1, 2, 3, 4. I'll probably have 5 up here. 1, 2, 3, 4. All right. So some persons, right? Not some persons, but it depends on how they want to think about it. Um, what what you can do is to go back to y equal mx plus c for guidance. As I say, I'm not going to repeat in detail what was done before, but y equal mxc is the equation of a straight line, and you can always go to this for guidance, right? Where c would represent the intercept on the y-axis, and of course you have your gradient or slope. No, that is the m. Let me underline the right thing. M is the gradient or the slope, and then you have your x coordinates here and your y coordinate here. So for example, you can rewrite this as y equal or y is greater than, and you can just put your 4 and put minus x. So this is a way you can rewrite it. Cool. But really and truly, what you're interested in is just to draw the line for now. So you use this to draw the line for now, right? Then you think about which side um, is the shaded region. So we know how to draw this line. So you can start off with x equals 0. So you can even plot some points. So you know, for example, that this thing is a negative slope. So you start off with x equals 0. So here you know that your starting point is here. Now you don't have to literally go through, you just need some key points. So x equals 0 is a key point, and y equals 0 is another key point. So if you can figure those two out, you're good. So when x equals 0, we know that y, I don't know how this thing is in the thing. Anyway, y equals 4. So that's a point there. 0, 4. And then the other one, when y equals 0, when y equals 0, that means x equal 4. So this is another point here. So if you can find these 2 points, you win, right? 4, 0. And connect these two. Thinking about the ruler, let me try. You connect these two. Ain't good. Let me see. All right, so I think this is probably the best I can get it for now. All right. Boom. Now it's a matter of determining which side is a shaded region. Is it that you want this side or you want this side? Now, an easy way, right, that way I normally think of it is, well, you have several ways. X plus y is greater than or equal to 4. So you can choose an extreme. This is what I mean. Over here, you would have, say you have 4, 3. 4 plus 3, so remember, this is a x plus y. So whatever satisfies this condition, you're good. X plus y is greater than 4. So 4, 3. So x is 4, y is 3. 4 plus 3 is greater than, 4 plus 3 is 7, which is greater than 4. So definitely the shaded region is on this side. All I did was just to choose a point over here or here. So that's one way. And I guess there are other easy ways of doing it, but this way comes to mind, and it's a way that has been reliable for me. So you choose one of the sides, here or here. Say you were to choose this side. You choose you choose a manageable coordinate too. So for example, you choose here. This is 1, 1, x equal 1, y equal 1. 1 plus 1 is 2. Clearly, 2 is not greater than equal to 4, so it couldn't be this side. It would have to be this side. So let me clean up here. At least try to. So you know that your shaded region must lie over this side. So let me try and, I guess, can use this and shade it up. So your shaded region must lie over this side. So again, when you get the equation, rewrite it in this format. You're just making y the subject of the formula. Say here, x plus y is greater than or equal to 4. You can think of it as an equality first. X plus y is equal to 4. Make y the subject of the formula to get it in this form. So you have y. So you know that in this case, 4 is the intercept. Of course, you know, if you want to make it look like that exactly, it would be something like this. Right? It's the same thing. So don't get hung up on that. So 4 is your y-intercept. And then you can determine, so like I say, what is the value of y when x equals 0? That is your y-intercept, 4. And then so you can say, what is the value of x when y equals 0? And in this case, you know, I think we got 4 too. So, and then you draw, you plot you just need the two endpoints where you cut the y-axis and x-axis, and then you determine which side is the shaded side. Ain't good. All right, moving right along. And of course, we'll make the difference between the dash and the regular line. Here now, it says shade the region which satisfy the inequality y is greater than or equal to 4x minus 7. Right? So again, you set it up. See it here, you have the intercept with cut minus 7. So you know where it cut the y-axis, you can test where it cut the x-axis. And then you're good to go. From I know where it cut the y and the x, and I just draw a straight line through it. So here, if x is equal to if x is equal to 0, we know that y is equal to minus 7. So get that point. When y is equal to 0, and we'll solve for this. So my strategy would be I would have I think this is the equation. So we know that when x is equal to 0, we know that y is equal to minus 7. So we'll have that coordinate. And then the other one is, for me, is when y is equal to 0, x is equal to what? And you can solve. So I have this implying that. So we can put 7 for x is equal to 7 over 4, right? So this is like 1, 3 over 4, so almost 2. So when I go here now, oh, let me put the coordinates. So we have the coordinate that you're working with is 1 and 3 over 4, or you can just say 1, since I'm going to put it on a graph, sometimes easy for me to think in decimal here, and 0. So when I come back here, I know I have these two working with. I cut this, I have this point and I have this point, and I just draw a ruler right through. Now, the other part says you need to choose which side, right? It's say I want y being greater than equal to 4. Let me see. Like y greater than equal to 4, x minus 7. So you need to choose a side. It's either you choose this side or you choose this side, right? So what can we do to determine that? Let's see. So as I said before, you choose some points and you say what satisfy the inequality. So if I was to choose a point, so let me know. Say let me go to the top. You choose a side. Say you have this side and you have this side. if you were to choose, say, a point outside 3, 2, let's say if 3, 2 satisfy this inequality. So if you put x equal 3, you get 4 3 is 12 minus 7, you get 5. So you get 5 on this side. I remember saying, no, why would that equal 2? Is 2 greater than or equal to 5? No. So if it's not true on this side, then it's the other side you're working with. So the other side will be the shaded region, right? So, and that's how it's done. So it's just a read through, go back to the video again and see. Here's another one. Shade the region would satisfy the inequality. So on so. Again, you draw up your line. You see how them are going through all the things like them have multiple points right here. You know, I just use 2 points. The y, the y-intercept, x-intercept, and I'm good. And then it comes down again, which side to choose. You look and you say, all right, if I choose this side or I choose this side, which side satisfies the inequality? And that even, let me even go around here. Because even at this point, you could have used the same strategy. So if you never use it with a tab, you could use it at the bottom. You choose a point. Say you choose, let me see. I think last time they choose, I don't remember, they choose what, 3, 4. Say you choose 3, 4 again. This time you're looking at this one. So this one is easy. 3 plus 4, 7. And you know 7 is greater than 4. But say you choose it here. 3, 4, 4, 3. I think it was 4, 3. Same difference, but 4 here, 3 here. 4 minus 4 is 0, and 3 is greater than 0, right? So either one would work. If you choose a stop, you just need to choose a point on either side of the line. Whichever one satisfied is a shaded region. If the other side don't satisfy it, then is the other side is a shaded region. So we'll go back here. All right. Yeah, and so for this, x plus 2y less than 10, you choose a point. So this is after you figure out the line. Choose a point 2, 3, you put 2 here, and 3 here. So 2, 3, 6, 6, plus 2, 8, 8 less than 10, then that means this side here is the shaded region. Good stuff. So look at questions. Like, you guys need to work these things out. You need to try them out, right? All right. So dealing with more than one inequality. So guys, this is what we really wanted. This is what we have been building up to. This is what we want to get to, right? This here, where it gets interesting. So we're going to take a quick break. Let me take a quick, I'll give you guys a quick 2-minute break and come back, right? All right, so we reach this section now that says dealing with more than one inequality. And yeah, and it will build up to, as I said before, linear programming. All right. So let's say if more than one inequality has to be satisfied, then the required region will have more than one boundary. The diagram below shows inequalities. X is greater than or equal to 1. So x is greater than or equal to 1 is over here. So this direction. X is greater than or equal to 1. Not x, y is greater than or equal to 1 is above here. And then you have x plus y less than or equal to 6. So you have this, and then it's over this section. So the triangle indicated by bold lines has 3 shadings. The points inside this region, including those points on each of the boundaries, satisfy all three inequalities. Very important here. And just quickly, oh, I like this. They actually broke it down here. So find a region which satisfies the inequalities. X is less than 4, y is less than 2x, and y is greater than x plus 1. So x is less than 4. So I have 4. X is less than 4 is just to the left of 4. So everything to the left of 4. Then y is less than or equal to 2x. So 2x, y equal 2x is this line here. Watch the line. Then it says y is less than or equal to 2x. So if we were to choose, say choose 2 points. So remember, this is the line y equal 2x. Now you're looking for 2x greater than y. So if you choose 2 points, say you choose here and here. So if you choose 3, so if you put x equal to 3, then you have 2 times 3, which is 6. So if you chose these, so 6 would be greater than 6 would be greater than what I have here. Let me go again. 3, 4, right? So 6 would be greater than 4. So definitely this side would be the shaded side, right? For this piece here, y less than 2x. So far you have x is less than 4 and you have 2x is greater than y. So where both of them overlap is in this region right here. All right, then you have another one now, y is greater than or equal to x plus 1. So x plus 1 is this. See there? From, remember, x, when x is 0, y is 1. So that's the y-intercept. And then the gradient going up is 1. So it's just something going up like this. So this is y equal x plus 1. And then let's check out the inequality. Y must be greater than or equal to x plus 1. So if you choose a point here, this is a 5, 1. So 5 is greater than x plus 1, and x is 1 here. So 5 is greater than 2. So definitely over this side. So when I combine all of them now to see where all of these shaded region overlap. You see that all of them overlap in this region here. This region right here. So the coordinates of its vertices can be seen from the diagram. So here you have 1, 2. So, coordinates of the vertices, just like the sharp edges, right? You have this sharp edge, this corner, sharp edge corner here, here. So you have 1, 2, you have 4, 5, and you have 4, 8. So these are very important for linear programming, and you'll see when a large number of inequalities are involved and therefore a great amount of shading, the required region becomes more difficult to see on a graph. Therefore, it is better to shade out rather shade in, leaving the required region unshaded. This method is used in the following example where shadow shading indicates the side of the line which does not satisfy the relevant inequality. The region where all the inequalities are true is called feasible region. All points inside the feasible region satisfy all inequalities. So that's interesting. They call it shadow shading. Well, for us, I'm not going to even try. I'm not going to confuse the thing. Just shade it in different directions, right? And it should be good. I'm not going to do any shadow shading. The shading thing in different directions where it overlap is good. Now these two examples are critical. These are key because after these two examples, I call it a day. And then we can pick up later some other time to discuss. So this example, a small factory employs people at 2 rates of pay. The maximum number of people who can be employed is 10. More workers are employed on the lower rate than on the higher rate. Describe the situation using inequalities and draw a graph to show the feasible region in which they are satisfied. Remember, the feasible region is where all inequalities are true, and that is the feasible region. So let X equal the number of people or number employed at the lower rate of pay, Y number of people or number employed at the higher rate of pay. It says the maximum number of people who can be employed is 10. So X plus Y is less than 10. It says so, it said the maximum number of people who can be employed is 10. So if this is number of people at one rate and Y is number of people at another rate, then the total number of people is X plus Y, and that must not pass 10. So X plus Y is less than or equal to 10. Right here, it says some more things. It's a more workers are employed on the lower rate than on the higher rate. So X must be less than, let me say, more people, X must be greater than Y. Because more people are employed at the lower rate than the higher rate. So X must be greater than Y. So already I have this inequality, you have this inequality, and then it says here, as neither X nor Y can be negative, then X must be greater than or equal to 0, Y must be greater than or equal to 0. And that's fair enough because these X and Y represents number of people, right? And you can't have a negative number of people. All right. So if I were to, so this is the answer right here now, but if we were to look on it on our own, let's get rid of these. So we draw something. All right, let's try this out. I'm not sure why this thing is here. Let me see if it will come back. All right, fine. Not going to fight it. All right, so say I have, all right. Then let's try. This thing taking forever to turn, man. All right. So let's try down here. So what we're working with, it says maximum people, 10. Employed at the lower rate must be greater than those employed at a higher rate. And X must be greater than 0, Y is greater than 0. So from before, so let me say 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. Lovely. So already we can do X plus Y is less than 10 would be this line here. Let me make an attempt. All right. And if it's less than 10, then it's the region is over this side. Right, so somewhere here. And then we have X is greater than Y. So we know that X equal Y is a line through the origin, a diagonal line through the origin. All right, give me a second to fix this thing properly. All right, so at 45 degrees should describe it. All right. So we have something like this. and it is x greater than y. So you can see that if you choose a point here, 4 is greater than, so 4 is greater than 1, so definitely over this side. So if we were to shade it another way, it would look like so. All right, so we'll have this being, this is y equal x, and this is x plus y equal to 10 here. All right, so, and we know that here, x is greater than 0 would be everything over this side, x greater than 0, everything over this side. So going across, x greater than 0 is everything over this side. And y greater than 0 is everything going up. But from what we can see, the region that we're concerned about is here. This area, this region right here, is overlapped by all the shades. So this is a region that we're concerned about. Of course, within the border, right? Kind of hard to get it done properly. Let me try again. So within the lines, this is what we're concerned about. And then shade, 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 shade. You get the point. So this shaded region in green would be our feasible region, or is it feasibility? Let me make sure. It says a feasible region. And what else they ask? They say, describe the situation using inequalities, drag up to show the feasible region. All right, so we did that. And so often there's a linear objective, profit or something similar for which we need to find its optimal value. Subject to a number of inequalities, this is called linear programming, and it is an important topic. We can solve linear programming problems easily by finding the value of the objective function at each vertex of the feasible region. The maximum and minimum values must occur at a vertex of the feasible region. We will illustrate this method in work example 3. So even before going to example 3, we know that in green is the feasible region, and the vertex or vertices here, if we were to try and maximize or minimize the function, whatever objective, linear programming objective, it would take place at one of these points. Right? So I'm not going to say any more about it than to say it would take place at one of these vertices. All right. Then we'll move to the next question now, which will have an objective, and we will see. The shaded region in the diagram below shows a solution of a set of inequalities in x and y. The variable x represents the number of boys in a cricket club, and y represents the number of girls in the cricket club. So to show the feasible region here, see here you have this is y equal 2x. So I guess this is what 2x being greater than y, so that it go over here, and then this is what let's show it. What else? I have 15, some other function. So the see there, this one right here. So this is the equation of this line. So this equation, and then I have this line right here. Right? This is what 2.5. So probably somewhere just below 2.5. So it says use a graph above to answer the questions which follow. State using arguments based on a graph whether the cricket club can have as members 10 boys and 5 girls, 6 girls and 6 girls, and it goes down, right? Now the set of 3 inequalities that define the shaded region, and then it goes down. So let us see. The first question, state using arguments based on a graph whether the cricket club can have as members 10 boys and 5 girls. It's a no, as 10, 5 is not in the feasible region. All right, so 10, 5. So going back to what it said, we have to make sure we know what X and Y represent clear as day. It said the variable X represent the number of boys and Y represent the number of girls, right? So X, so when them say 10, 5 now, 10 is here and 5, 10, 5 is right here. So 10, 5 is just outside the feasible region here. So 10, 5 is here, right? So as the answer said, no, at this point is not in the feasible region. 6 boys, 6 girls. So whether the cricket club can have 6 boys, 6 girls. When we look, 6 boys will be about here. And then 6 girls will be about here. So literally, let me see. So this is about 7.5 for argument's sake. And then 6 probably around here. And then 6 here, man. So definitely we can have 6 boys and 6 girls. So they land in the feasible region. So right now, a set of 3 inequalities that define the shaded region. So as I was saying before, you have um, y less than 2x. This one is, oh no, this is less than, I want to know how to say. But let us see. So y less than minus 4x over 5 plus 12, y greater than 2, and y less than or equal to 2x. Right, so those are describe what's going on here. And for this one, you could have said, but you just keep choosing a point. So once you know that this is the line, you choose a point here or here. So if you chose, say you chose a point 5, 5, then if you plug 5 into all of this, 5 that cancel, you get minus 4 plus 12, you get 8, and you get 5 right here. So I get 5, 5, and if you put 5 here, so minus 4, then I get 5. 5 would be less than 8. So this is definitely y less than this thing here, y less than minus 4 or 5x plus 12. And that's what it says here. So just keep remember to choose a point to the left from that on either side, or just one side. Because if you're right on one side, then the other side you have to check. But if you're wrong on the side that you chose first, then the other side is right. Then it says no, right? So a company sells uniform for the club and makes a profit of $3 on boys uniform and $5 on girl uniform. So write an expression in X that represents the total profit made by the company. Right? So it's just a number of uniforms you sell between the boys and the girls, right? So if X is the number of boys, and we can go up to remind ourselves, X represents the number of boys, then it's 3X plus 5Y. And that would be it. Then so calculate the minimum profit the company can make. So if when you have that formula, you have 3x plus 5y. That is your profit function. In order to determine the minimum, you're going to try the different vertices and see, because it's at one of these that your function either minimize or maximize. So when you look, it's the vertices are at 1, 2. So I'll go again. 1, 2. So I guess this would be 1, 2 here. And you go again 4 and 2, 7 over 8 and 4, 7. Right? Which should be somewhere, I guess, up here. And then the other one is 12 and a half and 2. So 12 and a half and 2. So you try them. And what do I mean by try them? You literally substitute the values. So let me show you. New, you literally substitute the values. All right, this is giving trouble now. So I think the function was, their profit function is 3x plus 5y. So you're going to try these values and see. So you have 1, 2, you have 1, 2 over 7, and 8 and 4 over 7. And the next one is 12 and a half and 2. So you literally try them. So when equal 1, y equal 2, you have 3, you substitute x equal 1, 5, and 2 on what you get. You get 13. And then you try another one, you try the other one, because you're looking to see what values would give it the smallest amount. But common sense can tell you that this would give it the smallest amount because all these other values are bigger than 1 and 2. If you look at even this one, 2, 2, they're the same here, the same y values, but the x values are far different. So let me big this up. So if they're asking you about finding the minimum, you could just use this alone because it is the smallest, it would yield the smallest value just by observation. As I say, 1, 2, these now are bigger, 4 and 2, 7, 8 and 4, 7, 12 and a half and 2. So here you have 2, and here you have 2. So that not going to make sense. If we were to compare this, these are on level playing field when it comes to the y values. But when you look at the x value, 1 is vastly smaller than 12 and a half. So you know for sure that this coordinate of 1, 2 would give you the minimum value in this function, right?
Yes.
That is the smallest value, right? When you try the others now, and usually they would set up the question that it's not so easy to just look at the values and know what give you the minimum maximum. For example, instead of having 1, 2 here, or say 1, 2 is here, this could be um this could be 3 right here. Say I had, or even better, this could have been 1. You could have had a 1 right here. So cool. And you could have had, instead of 12 and a half, because literally 12 and a half is big, than 3 times 12 and a half, that's big. You could have a 3 right here. Let me see. And you could have said 0 right here. Say I had 0 and 3, for argument's sake. 3 5s 15. So it, boy, we can't make it that easier. I guess we'll have to find an example to see where you can't just eyeball it and tell that this would give you the smaller value and this would give um this look like it would give a larger value than this one. All right, so this probably is a good example because I can eyeball these two and tell you that this would definitely give you a bigger value than this, or this would definitely give you a bigger value than this. So let us see what the values look like here. See there, if you were to use this and this, one I give you 55 and 5 over 7, and I want to give you 47 and a half. So if they were asking about maximum profit now, you definitely would have to work it out because it's not so easy to eyeball and see which one of these sets of values would give you the biggest value in the function, right? So that's the point I was trying to make. But since we're dealing with a minimum, you can just eyeball it and okay, 1, 2, 1, 2 is smaller than all of these. So if you substitute 1, 2, then definitely you're gonna get a smaller value, which is a minimum. All right. Then we look. So what I would say, definitely try these questions, yo. On a suitable set of axes, show by the shading the region which satisfy both inequalities. So you do the shading, and I would say, if you go down to the linear programming part, that's where you get most of the practice. So I would say do the linear programming part. Yeah, I would say. All right, let me give a direct instructions. Try 4, 5, and 6. Let us do 4, 5, and 6. Prepare 4, 5, and 6 for next class. And we can probably do it in the week, 4, 5, and 6. Right?
Okay, sir.
I think that's good practice. And do
So you're
try
going
to.
to post,
I'll put
are
it
you
in a
going to
group.
repost this start? Okay, sir.
Yeah, man, I'll put it in a group. So 4, 5, and 6, as well as I'm going to put in the solutions too. But don't look at the
Okay.
solutions yet until after you try your hardest work, the question after you watch a video, just in case you're stuck. But try and wrestle with it. Use graph paper if you have graph paper, and see how you can do it. Yeah.
Okay.
Yeah. So I'll leave it there for today. So I'll put it in the group with a solution and then we'll look at it in the week. So 4, 5, and 6. This is page 22.
Okay, sir.
All right. So
Yes, sir.
page 20. Well, it's a page 21 right here. So 22 in the PDF. All right. So later.
All right, sir. Have a good day.
Yeah, man. You too. Take care. Alison was there.
Yes.
Alison. All right, so you know what you
Okay.
need to do. So 4, 5, and 6. So I'll drop it in the group later.
Yes, I heard you. Yes, sir. Thank you.